This meeting is being recorded.
In problem 16 from chapter 9, we're given some structures here, A through D, and we're told that these enols cannot be isolated because they rapidly tautomerize to produce ketones. So an enol, if you recall, has that ene in it because it has a pi bond, it has a double bond, and then because of that alcohol substituent, we add that all ending to that. So that's what an enol is, a pi bond and an alcohol group in the same compound. So these cannot be isolated. They turn into ketones, and we are going to draw under acid catalyzed conditions what this mechanism of formation is. So I have drawn out for our first compound A here. We start with our enol, and then we see here our hydronium. So we have acid catalyzed conditions. What happens is that the pi bond grabs one of these protons. Those electrons move in to form water. And then what we've created here is a carbocation. So now in our second structure here, these electrons will move down, and we see this other structure here now has a double bond to the oxygen, and that positive one formal charge has moved up to the oxygen. So we've pushed a few electrons. Now what happens here, this water molecule grabs this proton, these electrons move in, and now we have fully generated our ketone. So something similar happens in reaction B down here. So we see our enol listed or drawn out. We have our hydronium for our acid catalyzed conditions. So that pi bond grabs a proton, electrons move on to form a water molecule here. And then we forgot to draw these lone pairs here. So one of these lone pairs will move in, form the double bond that you see. The positive charge on that carbon will be neutralized, but a new positive charge up here will be created on that oxygen. So what we see in this last step here is deprotonation, movement of those electrons from that hydrogen bond onto the oxygen, and then our final ketone is created over here.